Good morning, everyone. Again, my name is Tony Belter, and I've been working with Vision for a number of years. And, we do these every year. And over the past several years, my webinars have been basically product based, looking at features and certain aspects of the products that we sell. This month, what I wanted to focus on was lighting, and in particular, methods of lighting. Throughout the year, or years, I often get questions about lighting, or I get questions about part numbers for pieces of hardware to correct a lighting situation. And it comes to my attention that not everybody understands some of the aspects of lighting targets. Most of them are very straightforward, but every once in a while you'll get a target that requires a little more thought to light it. And so what I wanted to do here today was address some of those types of situations. And even though I have a PowerPoint here, there's not too many slides in this. This is really just to kind of key me into where I want to go next. This is going to be live demo stuff. I've got two cameras hooked up on either side of me here. One's a monochrome camera, one's a color. And I'm going to show you real world situations. These are live, so it's kind of like live TV. Things can go wrong. But I think it's more realistic when you see me do these things live in front of you, and you can kind of grab the point a little bit better. If you have questions, as Jeff said, just type them into the box, and we'll certainly take care of those. So right now, I'm going to just start with this PowerPoint, and then we're going to jump right into some live camera stuff. Instead of going to slideshow mode, I'm just going to leave it in this mode. You can see the screen well enough. And so I'm going to start by talking about, well, there's different lighting platforms, lots of different types of vision lights, and a lot of them have these buzzwords that people like to use, like dark field illuminator and cloudy day illuminator and all that stuff. Basically, most applications are lit from the front. Of course, there are some backlighting applications, and then there's some unique things that you can do with lighting. But for the most part, these are the types of common lights that you'll see in a vision application. You've got some linear arrays and some area lights, ring lights, which we'll discuss in some detail, backlights, some spotlights, and different types of things like that. And we're going to cover some of those, not all of them, but we'll cover some of those here today. The other thing I want to touch on is lighting wavelengths, and that comes into play when you have some unique targets. Although a lot of this applies to just about every target. But these are the spectrums that we normally deal with. So we do some ultraviolet, but blue, green, and red, these are the colors of LEDs that we use quite often to illuminate parts. We also use white, which encompasses all of the colors of the spectrum. We normally use white light when we have a color camera involved because we want to get the true color of the target back into the camera. And sometimes we use color to create different contrasts in different situations, and I'll touch upon that in this demonstration. And then, of course, we've got some infrared that we deal with when we have problems with ambient lighting, and I'll talk a little bit about that. Filters, lots of different kinds of filters out there. For people that are heavy into photography, they're pretty familiar with filters and to get different types of contrast and aspects of the pictures that they're taking. And machine vision, we use these things to either enhance contrast, create contrast, or to block out something that we really don't want in the image. And so I'm going to talk a little bit about bandpass filters, long pass filters, and some polarizing filters. And I find that polarizing is one of the most misunderstood categories of machine vision. I can't tell you how many often I'll get a phone call saying, I need a polarizing filter, I've got some glare. And so I'm going to address that a little bit too, so that we have a better understanding of what that is. But most of the stuff I'm going to cover today, we're going to be focusing on lighting targets from the front. I'm not really going to touch upon backlighting, but I do have an example at the end that will show backlighting. Backlighting is fairly straightforward. You put a light behind your target, and you get a silhouette, and you go from there. It's great for measuring and things like that. And I do have a real-world example of a backlit application, and I'll say that towards the end. So just to get a couple of terms out of the way, light is energy, And these are the four things that we talk about when we think about lighting. You've got an incoming light or the incident ray, and we have three conditions. You get reflected light, which is what we see most of the time, especially when you're front lighting. You're looking at reflected energy. We do have absorbed energy and re-emitted, and I'll touch upon that towards the end. That has a lot to do with fluorescing and things like that. And then there's transmitted light, where light actually passes through the target. I don't come across those situations very often, so I'm going to kind of steer clear of that one today. So let's talk about front lighting. And in front lighting, most of the time, we're going to be dealing with reflected energy. And when we do, and I really need to stress this point, is the reflection geometry. Sometimes when you get unwanted lighting situations on your target, many people will just want to shoot right towards some type of filter to clean that up, or a different wavelength of energy. But most of the times it has to do with the geometry of the light. Geometry of the light and geometry of the camera are the two most important things when it comes to lighting a target for a vision application. And a lot of times people just have the light or the camera or both in a bad situation for that particular target, and you're not pulling out good contrast for whatever it is that they're trying to do in that particular situation. And so I really want to focus on geometry. And we're going to start. I'm going to jump into, I'm going to go to a live camera now. And so let me jump in here, figure out which camera I'm on. Bear with me a second. I got two cameras going to make sure I get the right one. Yeah, that's the one I want to be on. So right now, this is a monochrome camera. This is live. And what I've got is a worst case scenario for a background, and that's a mirror. So I've got a mirror down here, and you can see I've got some room lights up above that are reflecting in this mirror. So I got some ambient conditions here. But what you're looking at is this is a live picture. Here's my hand in front of the camera. Here's my hand behind the camera. And so this camera is actually looking straight down into a mirror. And of course, not all targets are going to be this reflective. This, again, is worst case scenario. But once in a while, you'll get targets, especially automotive pieces, where they're very shiny or they're chromed or something like that. And it is almost looking into a mirror. And so I want to show you some of the different things that we get when we do have a very shiny background, because the background is very important when you're trying to create contrast between your part and what is surrounding it. So if I turn on the ring light to this camera, obviously we flood things out. I'll take the exposure time down so that you can get a better idea of what we're looking at. So here's the backlight that's on the camera. I can turn this, and there's 4 LEDs in this backlight. And you can see them there, and I have a very low exposure time. And so as I bring the exposure up, you see that these things get a little bit brighter. You can see that the lens is right here in the middle. And if we were to put something down here in the front, I'll just take a business card and throw it in there. And you can see I'm getting a lot of glare off that card. The card has a glossy finish to it. And so in this situation, if I really wanted to look at this card, the geometry of the camera and the light, which are both on the same axis right now, is not the greatest way to light this particular target. And I really wanted to stress this one because in a lot of situations, people want to put a ring light on the camera and to light their target. And a ring light is, in some instances, it is a great way to light your target, which I'm going to show you here in a second. But in a lot of situations, it's not. Now, I know it's convenient. You've got your camera in a position where, you think about positioning your camera when you first look at an application. If it's an existing situation, you're adding a camera to it, you may have limitations on where you can put that camera. And so you found a place where you can put the camera, and maybe you don't have a lot of different places to put lights. And so the first thought is, well, let's just put a ring light on the camera, we'll light our part, and we'll go from there. And I want to point out that in a lot of situations, especially if you have a reflective area, that putting a ring light on the camera might not be the best situation, and for reasons like this. But I understand that it's convenient, and a lot of the newer vision cameras that are coming out, they fall under the terminology vision sensor, where they're smaller, they're less expensive, they're easier to program. They normally use a little M12 lens in them, and most of them have a built-in ring light on them. And it's a very convenient system to use. We certainly have been using a lot of them here over the past year and a half. And in many situations, it's small, it's inexpensive, and it gets the job done. And because the light is right on the camera, a lot of people like to go down that road because it is simpler. But there are situations where having the light at that geometry angle compared to where the lens is not an ideal situation. So you can see what a ring light does for this, and of course this is a mirror. I'm going to turn the ring light off now, and I'll bring the exposure time back up. This little light area over here on the left is a fixture that's up in the ceiling above me. So that actually is some ambient noise. So let me get this back up here where we can see it a little bit. And now I'm going to take an LED spotlight, and I'm going to demonstrate that angle of incidence. So if the light is at a particular angle to the perpendicular of the surface and the camera is at the same angle on the other side, we get a lot of reflection. And so I'm going to take the spotlight, and just so you can see it, here, this is the spotlight. I'll point it up towards the camera. This is just it's a blue LED spotlight. And so I'm going to come up above the camera here. I'm going to shine it down, and I'm at a pretty decent angle, and you can see the light, on the mirror. And of course, as I get closer to that angle of incidence, this is what happens. And so this is a situation that you really try to avoid, where the angle of light and the angle of the camera to the surface are at the same angle. And of course, it just kind of washes things out. And so this is where lighting geometry really comes into play. And as I move this thing over to the side, we see that we can get a little better picture. Again, the mirrors, I just used the mirror so that you could, for one thing, see where things were mounted. You can see where the camera's mounted, and you can see me moving the light around in the field of view. Now what I'm going to do is I'm going to take this mirror away. And what we have here is it's a black plastic surface. It's very shiny. I'll bring the light back up, and so you can see that it's a very shiny plastic surface. And so in some situations, whether that be a conveyor belt or some type of nesting that you have for your targets, and it could be a very similar situation where it's just shiny, and so we have to take this into account. And so I'm going to just put some device in here. I'll take a piece of metal, and I'll throw it in the middle here. And of course, that's room lighting that you're seeing lighting that thing up right now. But if I hit this with a structured light here, and as I come over, there's a lot of reflections on that part. And as I come off to the side, I can start to light this thing in different ways to make it look good. Let me turn it over so that we got a cavity in here. And again, room lighting is kind of doing a good job on that. So let me take the exposure time down, take some of the room lighting out. And now you can see that if I put this blue spotlight on here, I'm just kind of lighting it with the light that I intend to use. In a vision application, you're always trying to take ambient light out of the equation, because ambient light can change, especially if you have skylights or you have a lot of windows or something in the facility where the difference between day and night, or just a bright day and a dark day, you don't want that to affect your application. You want to put your own structured lighting on your target so that you have full control over what that target's going to look like to the camera, regardless of what the ambient light conditions are. You even might have a situation where you have overhead lights in the facility, and sometimes they go out, and it may be a day or two before maybe maintenance gets up there to fix that. Well, that could affect your vision application if you don't take that into account up front and put structured lighting on your target, so that if ambient lighting changes, it really doesn't make a difference here. And so you can see now that if I get too high on this, it actually doesn't look too bad. I mean, the background's kind of shiny, but the target looks pretty good. And so as I come off to the side, I'm not really able to light this part evenly from the side. So this may be a situation where the ring light actually works the best. So I'm going to turn the ring light back on. I apologize for the pauses in here. I do have to unscrew these lights and power them back up. And so here's a ring light, and this is just a white ring light, by the way. And so as I light that up, I'm going to adjust my exposure time to get this thing to look nice. And you can see that it's relatively evenly lit. What this is there's two parts. This was a real-world application, and so here's the part, and it has a weld nut in it in the bottom. And the goal was to make sure that the weld nut was there, and in some instances, in the right position, maybe centered or something like that. I'm going to zoom in on this a little bit so you can see better. And so let's just say, let's just keep this simple. In this particular application, maybe we just want to determine whether that well nut is in there or not. And again, I'm going to turn this sideways, turn the exposure up so you can see what this part is shaped like. This is just a big metal part, kind of like it's got a recessed area that nut is sitting in. And so here, the ring light on the camera actually lights the target up the best. And so in a situation like this, I may come in here and I'll just throw a quick tool on here just to show you how we might go about this. I'll take a picture. Maybe I just take a blob tool. I'll just draw a quick blob in here. I will tell it to go look for some dark blobs. It says it sees 5 dark blobs. There's 1, 2, 3, 4, there's 5. And so in order to pass or fail, maybe I say, well, you can come down to 4 and you can come up to 7. I just want to make sure that there's a nut in there. And so if I were to go to run on this, and again, I'm really not trying to show you the piece of hardware we're using for the vision system today. I'm just trying to show you, what the lighting does for this thing. And I'll just give it a manual trigger. And of course, this passes because it sees 5 blobs. And then if we get a part that the weld nut was not put in there, and we take a picture, this one's going to fail because it only sees 1 blob because it doesn't see those little weld feet on the sides of the weld nut, which, by the way, if we put it back in there, really create a nice situation and create those dark areas. Because these weld feet, they slope off. Light comes down from the ring light, hits those, and it goes in this direction. It doesn't return to the lens, so it makes a nice dark feature for us. I'm going to go back to Tools, take this off of here, and we'll go back, zoom out a little bit. And so that's an example of where I used front lighting to actually solve that particular situation. Let's see. We're on the shiny black surface. I'm going to take the ring light off. Matter of fact, I think I'm going to take the ring light right off the camera here. I'm done with this. And I want to show you, I'm going to go back to my PowerPoint presentation real quick. And so the geometry, the reflection geometry, when I was flooding out the camera, I had the light at a particular angle to perpendicular, and then the camera was at the opposite angle, and that's why we got a lot of reflection in there. Situations that you really try to avoid in most situations. Right now I've got a shiny black plastic surface underneath this camera, which is representative by this block down here. And so when we illuminate a shiny flat surface from a particular angle, that light's going to hit that surface, it's going to bounce off on the other side, and we're really not going to see much. And so I'm going to hook this spotlight back up and just give you a little demonstration of that. And sometimes we use that to our advantage, and sometimes it just kind of gets in the way. And we have to go live. And so just to show you, here's the light, I'm shining down. We do have the camera in here. I'll take this up. There's the camera up here. You can kind of see it there. So this is a really shiny surface. And if I take the light and come down from the top, of course you get a reflection. But if I come in from the side, there's really not a lot of light right in here. Because that's just hitting that surface. It's going off in the other direction. It's not returning to the camera. But if this particular surface has some texture to it, then this one really doesn't. It's a really reflective piece of plastic. But if it does have some reflective properties to it, and it does have some profile to it, it'll stand out if we light it this way. Some of the energy will come off of the light, some of it will be reflected off that surface, but if there's surface texture down here, some of that energy is going to be returned to the lens, and we can see it. And what we call that is actually dark field illumination. We're shining the light so that none of it really hits back to the lens unless we have a texture. What I'm going to do is I'm just going to take some salt. I'm going to sprinkle it on this surface. And so now you can see that even though that's a highly reflective surface, and I've got a very sharp angle on this light, the salt really kind of jumps out at us. So we've really created contrast. I wish I'd brought some pepper down here. The pepper doesn't show up quite as well, but it does show up. So even though the target wouldn't be white, because of the geometry of those little pieces that are on the surface, I'm getting energy that's returning back up to the lens, and that's what's represented by this arrow right here. And so we sometimes use that to our advantage. If I wanted to look at a surface for some abnormalities, and the abnormalities had profile to them, it either was protruding upward or had a divot going down into the piece, we would see it that way. And so this is a unique way to light things. Dark field illumination, which I'm going to go into a better explanation of that here in a second, is a good way to do that. Turns out, I'm going to dump this salt, clean this off, put it back under there. I now have some pepper. Somebody brought me some pepper. So I'll put some pepper on there, and you can see that that lights up fairly well too. So don't want to beat that one into the ground. If you have questions on that, obviously just type them in there, and we'll go to it. Just so you know too, when we get done here today, I'm in the office the rest of the day. So if you have any particular questions, anything you see here today, and you want to go into more detail, I'm always available to talk to customers. So just give me a call, and we can certainly approach some of these things a little bit better. Now I'm going to change the surface again, and I'm going to go to more of just a standard surface. This is really a green file folder. Yeah, it's got a little bit of texture to it. It's got a little bit of shine to it. So this is a little more realistic as to what we would normally see. And I'm just going to put a couple of different targets on here, just so you can see how things light up. This is just a filter. And of course, if I come down too steep, even with this one, see, I don't get a lot of reflection on this surface here in the background. So it's not overpowering, but I get a pretty decent image of this. And even if I come off at a steeper angle, my light's over here, and I'm coming off at a little bit of a steeper angle, you can see I can light that up. I can create a shadow on it over here. There's different things I can do with that. But that's a pretty good, I could do a lot of things with that image right there just with this light. And you can get a very similar thing with a ring light. Let me go back to the PowerPoint. We're done talking about that. And now I want to talk about bright field, dark field. And there is something called the lighting W. I've already demonstrated some of the things that we see in the W. For instance, if this was your camera, this is the way I have mine mounted right now. It's perpendicular to a surface. And any light that hits this surface that's inside this W, we call bright field, or bright field illumination, because any light that's coming in this red area on either side hits the surface, a lot of that energy is going to go back into the lens. Dark field, if any light source is out here in this dark field area and it hits this surface, no matter how it reflects, again, if there's not a lot of surface texture like the salt and pepper thing I just did, most energy that's going to originate over here on this side hits the surface is going to go off in this side, and we're not going to see it unless it has some type of texture or profile to it. And so when we light targets, putting the illumination in these blue areas, we call that dark field illumination. And then if we keep the illumination up here, like maybe a ring light or some area lights or linear arrays that are up in this area, that's considered to be bright field illumination. So when you hear bright field, dark field, this is really what they're talking about. There are particular pieces of hardware, lights, that are called dark field illuminators. And I'm about to get one out here and show you what that looks like and show you what we can do with it. And because there are certain situations where a dark field illuminator works really well, it tends to get people to want to migrate to it really quickly. And so I hear the term, hey, did you try a dark field illuminator? Dark field illuminators are very specific lights, and they're made for very specific situations, which I'm about to show you. And so they are good lights, but in reality, dark field illuminator and all the applications I look at are probably used less than 5% of the time. Well, maybe less than 10% of the time. There are situations where it's absolutely necessary, and I'm going to show you an example that's just kind of cool to look at, and then I'm going to show you an example that it's really the best way to light a particular target to do a particular task. So, one more slide here. Sometimes the surface that you're looking at is nonlinear, and so maybe it's a curved surface. And when it is like that, the bright field area of your W gets wider. and your dark field area gets much smaller. Just wanted to point that out because not all surfaces that you're going to look at are going to be a linear surface. And so in some instances, we actually are looking at, we're looking at a nonlinear surface. We'll go to ring lights. I already did my ring light presentation. So now I want to come over here and show you something in the low angle light, or what we call a dark field illuminator. And this is a picture of what a dark field illuminator looks like. There's lots of different manufacturers of these things out there. The one I'm going to use here today actually is this particular model right here. So that's what I'm going to be putting on the target. And so what I'm going to do now is I'm going to go live. And I have the ring light off the camera. And so we just got a camera here. And the dark field illuminator that I'm going to use right now, let me plug it in, is actually red LEDs, which you're not going to see with this monochrome camera. And so I'm just going to lay it over here in front of the camera. And you can see, I'll take the exposure time down, that there's just a ring of LEDs inside here that are all kind of pointed at each other. And so what they do is they create a curtain of light, and when something comes up into that curtain, it kind of glows. So I'll just put my finger in here, and you can see that it does a really good job of lighting that up when it's in a particular position. And so when it's not in that position, everything else is kind of dark in there. And so what I'm going to do is, this is an example I like to use, is I'm going to put a quarter in the field of view, and I am going to actually get this ring light back again. I'm just going to hold it up here. So I've got a quarter, and it's in the field of view, and you can see it there. And depending on my exposure time, you can kind of wash that thing out. And so let me get an exposure time. If I get it really dark, you can start to make out a few features. You can make out a few features here. But most of a shiny surface like that, and I'm using a quarter as an example because everybody knows that George doesn't have very much profile on a quarter. He is raised. So there is some profile, but it's not very much. It's certainly less than a millimeter. And so in this situation, a front light like this doesn't really do a good job of pulling out features in a target like that. Highly reflective target, very low profile to it. And so this light isn't really the way to go. But, and I'll zoom in on this, I'm going to set a couple of fixtures in here, and I'm going to put this dark field illuminator in here. And I'm going to put, now I'm not talking about filters right now, but I am going to put a red filter. Before I put the red filter in there, as you can look at your images, can you see fluctuations out here on this white surface of the back of this dark field illuminator? And what those fluctuations are is I'm sitting in a conference room with overhead lighting, and some of the bulbs are T12s, which are on 60 cycle, they're on chemical ballasts. Magnetic ballasts, and so you can see the 60 hertz ripple in those lights, where if you go to a T8 with electronic ballast, you start to lose that stuff. But there are some situations where ambient lighting can still be a problem on a target if it fluctuates, and so that's what you see right here. And so to eliminate that, I'm going to put a red filter on my lens. And so now we've taken out the ambient light condition, so the only thing you can see is the red light. If I take the red light away, this whole thing is just black. And I can take the exposure time up quite a bit. And there is some red in white light, room lighting, but you can see that I've taken out most of the room lighting or the ambient lighting out of this. And so now when I put this in here and I adjust this exposure time down, this is what a dark field illuminator can do for you. So if I zoom in on this part, and I apologize for the focus, I had to set up in a hurry this morning. But you can see that we got a nice highlight on the outside of this coin because that's where the edge is. And so that light comes in, hits that surface, it has a profile, it shoots that energy up into the lens. And you get a really good, nice outline of George's head as it comes around here. And I can adjust the exposure time to bring out a few different features. So if I take the exposure up, things get a little bit brighter. If I take them down to where everything gets kind of dark, we still get a nice outline of George. And remember, he's less than a millimeter profile in this part. It's a very highly reflective part. I looked for as shiny a quarter as I could get. and it's a good demonstration for this particular light. The light needs to be very close to the target for this situation. And as I lower this light, I put it in my hand now. As I lower it, I can get different aspects of this thing. You can read the word Liberty a little bit better. The year at the bottom is 1996. Again, I apologize for the focus. But as I move it up, I get a little less of that profile. As I move it down towards the quarter, I get a little more profile in this thing. So the position of this light is critical to get the features that you want out of it. All right. It's nice to look at George, but let's do a real world example of something here. And so here's a real world target. And so I'm going to turn the exposure time up. And I'm going to take this red filter off and zoom out. And so what I have here is it's just a black adapter. And if I use front lighting on this adapter, it will light it up. It might not be the greatest of lights. I can flood it with bright field illumination, and I can start to pull some stuff out. But if I had to measure the diameter of a portion of this thing, this really wouldn't be the greatest lighting for me to use for this. Even though algorithms now in cameras are very strong, and I could probably go in there and pull something out to measure the diameter of this, but I don't know if it would be considered robust. I don't know if I would trust that over a long period of time. And so what I'm going to do now is I'm going to take the ring light away. And I'm going to put the red filter, because I'm going to use this red dark field illuminator. I'm going to put the red filter on here. I'm going to put this dark field illuminator. Now you can see me. I'm going to lower it down onto this target. And you can see what it's going to pull out as I do this. So as I get a little bit lower and lower and lower. Now I got a nice, I'm going to zoom in here so you can see it. Now I've got a nice white ring where the top of this adapter is. And I can actually see another ring down here that's recessed in there a little bit farther, so I actually could measure the diameter of that. And then here's an outer ring of this adapter. So I've really got 3 rings that I pulled out just with this one light and then the position that I put it in. And so in this situation, I'm going to actually put a tool on here and show you. So we'll go to Tools, take a circular tool, and let's just say I want to get this brighter one. So I could come in here and I'll click a few points, and it will automatically put a tool in there, and it will give me a diameter, and maybe I put a few more spokes in this thing. And it's telling me that, and of course this is all in pixels, that I got 125.8 pixels is the diameter of this particular target. So from one side to the other. And you know, it was a lot easier to pull that information out with this dark field illuminator. So that's a real world example of where I would use that. And we'll go back to a live camera. And I will take the slide away. Before I do that, I do want to show you this again. I'm going to pull out this part, and I'm just going to pick something here. I got a piece of metal. I'm going to put this dark field illuminator back in here, and of course this is just it's a big piece of metal. And so just to show you, if you just want to pull out some features, you can see I can just pull the tip of that out pretty well by using a light like this. I could probably pull it out fairly well with a front light or a ring light. But the dark field really starts to pull out some unique features of this thing, especially when you get down in this area here. You can pull out the edges of this and the edges of circles, and so it's a nice light to do some of those things. And I'm done with that. All right, we're back to a live picture. I'm going to take this red filter off the lens, bring the exposure up, just to make sure that we're still live. Yeah. All right. So that's the dark field illuminator. Again, shiny surface, you don't see a whole lot. As soon as there's some profile in that surface, we do get some return. Think of this as the salt and the pepper down here, and you do get some return to the lens, so it does show up. Filters. Let's talk a little bit about some filtering. Again, we've got bandpass filters, long pass filters, and polarizing filters. There are short pass. There are a lot of different types of filters, but these 3, actually the top 2 are the ones that I use the most. And I do use a polarizing filter from time and again, and I really want to stress something when we do get to the polarizing filter. And when we use filters, we need to have a little understanding of the electromagnetic spectrum that we're dealing with. We're dealing with the visible light of the electromagnetic spectrum. And so a lot of times the lights that we use in vision are red LED lights. And LED lights are very consistent. They keep their intensity over a long period of time, relatively inexpensive. And what's funny about that is I've been using LED lights for vision for over 20 years. And of course, in the past 5 or 6 years, LEDs have become more mainstream, and you see them in a lot of different situations. I mean, of course, you see them in home lighting now, but you see them in indicator lights, pilot lights. In the automotive industry, you see them as tail lights. And so in the next 5 years, everything is, if you see a light that's not an LED, that's going to be kind of a rare thing. And so these things have come into today's realm, and mainly because they use very little power. They do produce a little bit of heat, but that's getting better all the time. But they're very consistent on the illumination that they put out, and they stay that way until they basically just fail. And so we've been using red LEDs in vision for a long time, and we still do. The ones I use the most are probably red LEDs. I use a lot of blue LEDs, and then from time to time I'll use some infrared. Now, infrared is up here. It's a wave much longer than 700 nanometers. So anything over 700 nanometers in wavelength is in the infrared spectrum, and the infrared spectrum goes up quite a ways. And then, of course, below the violet spectrum, anything below 400 nanometers falls into the ultraviolet spectrum, and then, of course, then you get into other types of waves. But in the visible spectrum, this is where we are. Of course, we can't see infrared, but the cameras see them fairly well. The imagers, CMOS imagers that they put in cameras, and even the old CCD imagers that they put in cameras, were very responsive to the infrared end of the spectrum. And so they see pretty well into the infrared spectrum, way up into the 900 nanometers, 1,000 nanometer type things. And then ultraviolet, CCDs and CMOS imagers don't see ultraviolet energy extremely well. They're not that responsive to that particular wavelength, but when we use ultraviolet energy, we are generally using it to do something else for us. It's going to hit a target, and it's going to come off of that target at a different wavelength, and that different wavelength is going to be somewhere right in this area, and that's going to allow us to see things that way. And I'm going to save that just for a little bit, but I just wanted you to have a brief understanding of the spectrum that we're dealing with. And so the visible spectrum, we're really dealing anywhere from 400 nanometers to 700 nanometers, and I do hang out up here a lot in the red area. A lot of red LEDs that you can purchase are in the 625 to 635 nanometer range. And then, of course, you would put a filter on there just to allow that energy back through. But you can stray from that a little bit. You can go a little bit deeper into the red if you want to knock out more ambient lighting conditions. The other thing I want to point out here before we go back to a live camera is opposite colors. Another reason we use colored LEDs, other than them being inexpensive and bright, is that you can create certain contrast by using different color LEDs. For instance, if you have a target that is red, well, let's do this. Let me just let me go back to the live camera. This is a monochrome camera. It's time for me to move this around a little bit. And so now I'm going to point this off to the side. Here, just see I'm in a conference room. There's the overhead lighting. And so I'm going to point this like this. Try and get this cable out of the way. And I'm going to take a couple of targets that I found here in this conference room this morning. And one is a creamer. And one is a sugar. And I will show you this with a color camera here in a minute. But I know you can't see it in monochrome, but the creamer top up here, this is all blue. And the sugar, this is all red. And so if I were to put different colored wavelength lights on this, if I go back to this PowerPoint, if you use an opposite color, you can get, excuse me, you can get things to create more contrast. So for instance, on a blue target, which is the creamer, if I were to put a blue light, you're not, and of course there's white underneath it. So this is blue and this is white down here. And if I put a blue light on that, you'll notice that the blue really kind of starts to look a little bit like the white. Of course, that's kind of bright. But if I lower this exposure, you can see that it's kind of light. It's much lighter than it would appear when it was just grayscale. Of course, I'm kind of getting saturation right there, so I'm trying to get this thing off to the side. There we go. And so, there's the white and there's the blue. But if I come over here to this one, this is red and this is white. And so blue light makes red look very dark, but blue light makes blue look very light. And so if I wanted to pull contrast out of this, if I was looking at the red one, maybe I would use blue light to separate these two. This is kind of blue in here too, by the way. I may use blue light to separate these two contrasts a little bit better, but I certainly wouldn't want to use it over here because I don't have as great a contrast. But if I go to a red light, and I put it on this target now you can see that the red one, it looks kind of light. I don't have good contrast here, but on the blue target, I have great contrast. So again, this is an opposite color. Even though it shows green and red, blue, which is red in this area anyways, is opposite red and vice versa. So red light really makes these look darker, and blue and green light makes red and orange look a lot darker. And so that was the point I was trying to make here. And it's a good example. Glad I found those this morning. All right. So that's why we use different color lights. That's why we sometimes use filters. There are situations where if you already have a white light and you put a red filter on your lens, you kind of get the same thing as if you were using a red light. And the same thing with blue. If you had a white light and you put a blue filter on there, it's going to act as if you had a blue LED. Not spot on, but it's going to be close enough for you to use. And again, you can see this 60 hertz fluctuation in this room. Even if I brighten it up, I can kind of focus it out. All right. Let's talk about energy that's absorbed by a target. And what happens is when that energy is absorbed, it's actually re-emitted in a lot of instances. And so I'm going to come down here, and this is where fluorescing or using ultraviolet light comes into play. And so as a special case, well, I'm going to read this for you, but when photons go into a material and they're absorbed and they're re-emitted, they come out at a different wavelength, which is very useful to us. And of course, that's called fluorescence, or scientific terms, that's the Stokes shift. And so energy that's absorbed is re-emitted at a little bit different frequency. And that different frequency, from what I've found when you're using ultraviolet light, is it's going in at about 395 nanometers, very close to 4. It's very close to violet. 395 nanometers, and it's coming out at about 470, 480 to 520 nanometers. So it's really coming out at a very specific wavelength, and we can use that to our advantage. And so now I'm going to go to the color camera, and we'll start looking at some things over here. You know what? Before I go to fluorescence, I need to back up one because I forgot to talk about polarizers, and I'm going to do that right now. So I have a color camera over here, and I'm going to turn a red light on. And of course, it's shining on a table, and everything's 90 degrees here. I got my camera sideways. And what I've got is I've got a little cup of water. And what I wanted to do is I wanted to get those LEDs. I've got a red linear array over there, and those LEDs are shining right on that water. And I'm getting a really good reflection off that water. Now, I have a polarizing filter on this particular lens. Now, a polarizing filter, think of it as a pair of Venetian blinds. There are parallel lines across this polarizing filter. When energy hits a surface, it does a lot of different things. But when it's water, and I'm using water as an example because we all have polarized sunglasses, and when you wear those at the beach, when the sun comes out and hits the water, that energy from the sun is coming in unpolarized. It has waves in all different directions. And when it hits that water, it comes off the water polarized. Those light waves are now in a particular plane, and that plane of light is horizontal to the surface that it's reflected from, and that's water. And so when you have polarized sunglasses on, the lines that are in the sunglasses, the louvers, are running vertical. They're running perpendicular to the waves that are coming off, or the light waves that are coming off the water waves. And so what happens is those polarized sunglasses will block any of that reflected light coming off water, or what it would be as glare. It's blocking that glare. Same thing happens when sunlight bounces off asphalt. So when you're driving and you wear polarized sunglasses, which they're all polarized now, those lines of polarizations, by the way, are running vertical. When you put them on, they're running north-south in those glasses. And when light reflects off a horizontal surface, that light is polarized in that horizontal plane. And so your lines of polarization of your glasses are perpendicular to that reflection, which is glare, and it blocks that glare, and that's why it does that. And so right now, I'm simulating this because I got a little cup of water over here, and I'll push it over a little bit farther. You can see it jiggling around in there. And you can see the LEDs on this light over here. If I put my hand over here, I could probably block a couple of those. There's my hand going in front of those LEDs. And I've got a polarizing filter on this lens, and that polarizing filter, the lines of polarization are actually the same as the waves of light coming off that water. And so they're in the same orientation, and it allows that polarized light that's reflected off that water to come through that filter and into the camera. Now, if I rotate my polarizing filter towards the 90 degrees, what you're going to see is you're going to see me start to pinch off, because now these lines of polarization are becoming vertical. And as I get it over towards the 90 degree mark, I can just about eliminate all the reflection off that water. And of course, if I come back around where they're parallel, it gets very bright. You can also see that I'm eliminating some of the glare off the table. This is just it's just a wood grain table, and I'm getting a lot of reflections off that because that's some kind of mylar on there, or Formica. And so now what I'm going to do is I'm going to take a piece of metal, a piece of steel, and I'm going to stick it over here next to this water. I'm going to lower this exposure a little bit too. It's a little bright. And so right now, when energy hits water, that light energy comes in unpolarized. It hits water. The light energy reflecting off that water is polarized into the same plane as the horizontal of the water. When light energy hits metal, some of it, when it comes off the metal, is polarized, but most of it is not. And so now as I turn my polarizer ring on this particular target, you can see that I'm going to pinch off the reflection in the water because most of that energy is polarized. But I'm still getting glare off that metal. I did knock some of it down, but most of it is still reflecting off that steel. You can see I knocked down about 15% of it. I'm coming around the other side. And so it totally blocks coming off the water surface, but I'm still getting a pretty good reflection over here off this metal. And so I get a lot of customers that want to put polarizers on their cameras because they're getting reflections off of metal targets. And it will knock down a little bit of that reflection, but most of that energy that's coming off that steel is going to be unpolarized energy, and you're still going to have a glare off of it. So that's what this example was set up to do. So just wanted to show you that. And again, if you ever want to talk about this in a little more specific areas, you can give me a call here at the office, and I'll be more than happy to talk to you about that. So now what I'm going to do is one other thing. I'm going to turn this light off. I'm going to take this color camera, take the polarizer off. Put the camera perpendicular to the table. I'm going to turn the exposure up so you can see things. I don't really have any light on this. And just to show you what I'm thinking of it, there's the creamer and the sugar. And you can see that they were red and blue. And so that's what I used when I used the different colors of light to create contrast. But now I want to talk about this re-emittance. And so I'm going to use a UV light. And I have an ultraviolet light that's at 395 nanometers. Most LED lights come in either 395 or 365. You'll find that 365 nanometer ultraviolet lights generally cost more. They're a little more difficult to manufacture. 365 is generally used in the food industry. 395 is the kind of light, ultraviolet light you have in your backyard to draw bugs into your zapper. And in the food industry, you really don't want to draw bugs into a situation where you're using ultraviolet light when you're around food. So they'll tend to use the 365, which tends not to draw insects in. But you do pay a little bit more because those LEDs are a little bit harder to manufacture. And so now, what I'm going to do is I'm just going to take, I got a steno pad here. Brighten this up a little bit. And I have a yellow highlighter. And I have a special, this is just a regular yellow highlighter. And I have a special ultraviolet marker. And I'm going to shake that up. And I'm going to just draw a line with this ultraviolet marker. I'll try to make it kind of thick. It looks clear when you put it on. You can kind of see it there. And then I will take a yellow highlighter and put a line down here below it. And you can kind of see that one. And so what happens is the yellow highlighter actually has fluorescing capabilities. When ultraviolet light hits that, even though it's meant for you and I to see things better, there are fluorescing properties inside that yellow highlighter. So if I come over here with an ultraviolet light and I hit this, and I got to take the exposure time down for you guys to see this. They do fluoresce. Now, one was clear. The top one was, you can kind of see it right here. This was clear, and of course this was the yellow one. When I hit it with ultraviolet energy, they do fluoresce. But you'll notice that in here, I'm also seeing some of the ultraviolet energy bouncing off this paper. That's why it looks purple. That's why I'm using a color camera, so you can see that. Here's a glare off the paper because I'm at the angle of incidence. These CCDs do see, and these CMOS imagers do see ultraviolet energy. They do see that wavelength. But what I'm more interested in is I want to see what that wavelength, the 395, does to these other materials, and it's going to fluoresce those into a different wavelength. And that's the one that I'm really concerned about. That's the one that I really want to see. I don't really care about seeing the ultraviolet reflections. I just want to see what it's doing to these materials and the frequency that they're fluorescing into. And so what I'm going to do is I have a filter that I use when I fluoresce targets, and it's a bandpass filter. It allows wavelengths between, just below and just above whatever the setting is on the filter. And this is a bandpass 505 nanometer filter. And so it allows things down to, 475, 480, maybe all the way up to like 530. So I'm going to put that on there. I'm going to come back in here and fluoresce this. And now you see, I don't see so much of the ultraviolet bouncing off the paper because this particular bandpass filter, and most of them, actually have a built-in UV blocker. And so that UV blocker is going to block the reflected ultraviolet energy, which in 99% of the situations you get into with ultraviolet, you don't want to see that anyways. You only want to see the frequency that it fluoresces these things into. And if I come off this a little bit so I'm not saturating it, you can see that this yellow highlighter right here actually looks a little green. And then this UV marker that I use actually fluoresces into the blue. You can get different fluorescing agents that fluoresce to different frequencies. I've seen some that fluoresce into a magenta or maybe even almost a pink. And so they do make different UV accelerators that go to specific wavelengths, but most of them are going to go into the blue area, just the ones that you buy commonly out there. And so where would that come in handy in the real world? There's again, I'm just going to show it on there so you can see it. Move this around so you can see it's real. And so that can come in handy if you happen to have a target that has natural UV fluorescing in it, or they put some in. And so here's the situation. Here's an automotive part. I was testing it in the lab. And they were putting a clear material on here that was supposed to clean the area before they put some black felt pads on there, probably more of a eliminate squeaks and things like that in here. But they had to put the cleaner on there first so that these pads would stick, throughout the life of this thing. And it was hard to see that clear material. So I thought, well, let's just throw some UV energy at it to see if by any chance there's a UV accelerator in there or fluorescing agent. And there was. And you can see that they daubed this stuff on here. It actually showed up quite well. And so without the UV light, this was just clear liquid. I mean, it was a little shinier than the part. But it was very difficult for a camera to see. And so in this instance, when we put the UV light on there, that just popped right out. You could put an intensity sensor on there and measure that intensity, and you could make sure that they put that clear liquid on there to clean that area before they put these black felt pads in here. This piece already had the black pads put on it. There's one right here, here, and here. And I think there's one right here. And so it also made them stand out a little bit better because it fluoresced behind it. It really made them stand out, and I could actually check to make sure that those pads were there. So that's a real-world example of why you would use ultraviolet. Looking at the time, I'm near the end, and I think I'm going to end this seminar or this webinar today. I appreciate everybody coming today. I hope you got something out of this. Again, if you have specific questions, you can call me here at the office. My name is Tony Belter, and we will post this on our website. And 4 years ago, I did a similar one to this that went into a little bit deeper explanations of some of these things, and that's still posted up there too if you care to take a look at that. So with that, I'm going to wish you a good day.
Tony, thank you. Right now, we don't have any questions in the question box. We'll maybe wait a minute and see if anybody types any in. Other than that,